A few announcements first. Lab number 1 will be released. I will try. I'm still working on that, finalizing it, either tonight or tomorrow morning. You definitely get the instructions before your lab session. So because the Moodle has been very slow, what I will do is I'll send email attachment to you guys for the instructions. Okay, so please just get it. And there will be some starter code for you to work with, and also the instruction. I'll make sure you got both by email tonight or tomorrow morning. Okay, before your lab session. Yes.
Why don't you upload the lab on your website?
No, because it will be public. We want to keep the labs private. Okay. Okay, and unfortunately for office hour today, I need to leave earlier, so there'll be no office hours today. But if you want to speak to me, I'll be in the lab session both tomorrow, and also you can speak to me for the rest of the office hour this week. Just not today. Okay. Okay. The plan for today, I think, mainly is about design by contracts. There'll be certain different aspects I want to talk about. I want to go over the Java. We did the version number 1 a little bit in a rush last time. I would like to go over all the 5 versions because it's really important for you to see the different concepts, how you can do precondition, how you can do postcondition, and how you can do class invariants, the stuff in Java. And then I will show you how this can be done in IFO, and especially how the contracts can be checked at the runtime. It's really important to understand. I'll go over these in very much detail. You will need those for your lab number 1. And then for the remaining time, I'm going to go over some quick lecture there. I'll just give you some survival guide for IFO. I'll just highlight certain syntax that will be useful to you, okay, only for today. And then later on, you can pick it up by yourself or just ask me or on the forum. Okay, that's going to be the plan. But we'll still do Java to begin with. Okay, let's go to the slides. So now let me just review very quickly the problem that we're trying to solve. Remember, we talked about the requirements of a bank application. We got 2 requirements. Let's just review them very quickly. Requirements number 1, each account is associated with the name and also the balance, which should always be positive. And whenever you see always positive, you should really have the equivalent mathematical formula larger than 0, strictly. And then we may withdraw an integer amount from the account, and the requirement is intentionally vague. It doesn't really tell you whether the amount might be too large or negative. So that's really to your judgment. Okay? So now let's just briefly review version number 1 very quickly. Okay, that's the Java code. I'll just highlight important stuff for you. We criticize this initial fragment of Java code, which has no reflection about the contracts whatsoever. So that's why it's really bad. Especially, let me just point out a few things that's really bad. You can see over here, for the constructor of the class, the balance over here is never checked, whether that's negative or not. Let's say you just want to create an account of minus 100 million balance. That would be bad because it will be accepted, right? That's the first thing. And also, the amount that you want to withdraw is also unchecked. You can see there's no exception thrown from here. There's no error checking over here. So the amount can be either negative or maybe too large for you to withdraw, right? So these are the two things that's really bad about the first version. There's no reflection about the contracts, okay? Let's have a look at this slide very quickly just to see how the first version can go wrong. Okay, let's see over here. I just want to just give you one example over here. Let's say over here, we are trying to create an account, version 1, with minus 10 balance to begin with. But now you can see that if we simply try to execute this block of code, and by the way, all the versions of code is already available on the course website. You can definitely download it and play with it. So now you can see that if we try to execute a tester here, it simply tells you Alan's current balance is minus 10. That's pretty bad because from line number from this line over here, you can see I want to pinpoint to you this line here. As soon as you're trying to create an account of a negative balance, there should be some contract violation over here. Somehow to tell you that you're trying to give some illegal initial value. Okay? But for the first version there, it seems like the supplier, which is here, the supplier over here, this block of code, that's a supplier. The supplier gives you no indication about what can go wrong. So supplier is very ignorant. On the other hand, the client is also very ignorant because the client gives you something that's negative. So somehow this version here, we don't know who to blame because the fault is on both sides. That's not good. To really have a good design, you want to have exactly one side to blame if anything goes wrong. Okay, that's about the first version. So let's go on to see what the second version can look like. Okay, let's go to the second version, and the rest of the slides will be self-contained. Let's go to the second version. So now, first version, how should we improve it? Basically, let's say over here, let's just say, for example, let's say for this parameter over here, we want to somehow to tell the clients, if you're trying to call this constructor over here, be careful, because you might have some, for example, negative initial balance exception that might be thrown from the code, and that should be part of the API for this supplier over here. That's what we would like to improve. However, we want to be a little bit more precise about what precondition really means, okay? Let me just describe to you informally. Precondition really means under what circumstances should you provide the service that's required. And think about whether this English description here really matches what exception means in Java. Okay? Can anybody think about if they are really the same or different? Let me repeat again. Precondition should really be considered as under what circumstances should you provide the service that's required. It's more like a service condition. On the other hand, when we do this in Java back in 2030, the way we did it is to say, if you have certain condition, negative balance, for example, I'm going to give you an error, an exception. Do you think these two are really the same? Are they the same?
No, because exceptions occur when undefined behavior happens.
Yep, so exception basically like error conditions, right? But can you see any logical relationship between the two conditions? We talk about surface condition for preconditions, and we talk about error condition as exceptions. Any logical relationship?
Once for the supplier's way of doing it, and once depends on the client.
Not necessarily. Precondition should be considered for both sides. No, should be for both sides. The opposite. More formally, they are the logical negation of each other. Okay? Okay, let's keep that in mind, and I'll illustrate to you in the example. Okay, so now let's go back to the slides and try to go over some points over here. Okay, the precondition tells you under what circumstances should you call the method and give you the service. Okay, so for example, the precondition for this, what should that be? Y is not equal to 0. However, think about, for this example here, okay, now we talk about only when y is not equal to 0 am I going to give you the service. But think about what would you do in Java. You're going to say if y is equal to 0, I'll give you an exception. Op is exactly the negation of that. So to be very precise, the exception that we talk about so far, they are not exactly preconditions. They're kind of the logical negation. So there's some detour over here. It's kind of indirect. Okay, that's a criticism over here. Of course, you can argue that I can always do the logical negation of the precondition and do it in Java. But if you can get around from the conversion, why bother, right? Okay, that's something to think about. Okay, and this one is very easy. Binary search, we talk about it. Precondition. Exactly, exactly. Now, guys, I have a question for you. How about we review a little bit of math? Let's say we got XS, an array. Indices will be from 0 to XS dot length minus 1, right, in Java. How would you express the array is sorted in practical logic? Okay, let me just put a question over here. So the question is, I have, let's say, array of integer, let's call it XS. How can I express to say it is sorted? I'm talking about math, not Java code. Of course, to Java code, you can just have a Boolean variable and set it to false eventually, or otherwise you remain true, something like that. Okay? How would you do it? Yep. So you're talking about using two dummy variables, I and j. No, you don't need it. Just one dummy variable, just one. Anyone? Oh yeah, of course. How would you specify that in math, right? Okay, how about you? I plus 1 is bigger than I. Isn't that always true? You're talking about XS at I plus 1 is larger than, okay. You see, what you just said was, you say I plus 1 is greater than I. Isn't that tautology? It's always true, isn't it? Right? What you meant to say was, somehow XS at I plus 1 is larger than XS, I plus 1. I think that's what you meant to say. Oh yeah, I plus 1, right? Oh, you're right. I. Sorry. Yes. Yeah. How about that? Well, less than equal to. Okay. Okay, let's be formal. For every I such that 0 less than or equal to I less than xs dot length, it is the case xs I less than or equal to xs I plus 1. That's math. So now, you pretty much know how to do this in Java to get a Boolean value, right? It's not very convenient. How would you do this in IFO? Let me show you how it looks like in IFO as a preview. Okay? In IFO, let's see if the following thing will make sense to you. I'll just show you what it will be relevant to your lab 1. You will write lots of contracts like that. Let me just write it down at a page below. In IFO, it will look like something like this. Across is a keyword. XS is array, which is iterable, which means you can iterate through it. You know what? Let me just don't use array at the moment. Okay. Across, starting from 0 until xs.length minus 1. Okay, let's put a bracket here. S, I, and then put an n here. And then you would say xs at position I.item. The reason for putting this item here, I'll explain a little bit later. It's a little bit subtle. Okay, less than or equal to xs I.item plus 1. And the whole thing returns a Boolean. That's how you write in IFO. Okay, isn't that quite nice? You can express your math quite easily. And more importantly, this code is subject to execution and test at the runtime. Okay, question? Yes.
So does length exist in Java?
Which one?
And,
in IFO. Yes, it does. So everything I write here can be compiled. Okay? Yeah, I'm just trying to give you a preview. Questions there?
What is word on the last one? You missed the minus 1 on the
XS, yes. Yeah. No, actually that's fine. XS.length. No, it's a very good question. The question was, do you think this might do the same thing? Well, I say that it's only go until but not including xs.length. That means it only goes up to xs.length minus 1. Review your Java course. How about that? Oh, I see what you mean. Now you're talking. I didn't listen, sorry. I think you made a very valid point. This should be minus 1. Absolutely. That's fine, yeah. Okay, guys, you know why over here? Okay, it's very important over here. The reason I'm putting minus 1 here, there's a reason. Because remember, we are putting I plus 1 over here. That means the last value for dummy variable I must be xs.length minus 2. So when e plus 1, you will get to the last index. It's a very subtle point, but important. Okay, good. Anyway, that's about how you can express that. But you will see examples later. Okay, that's about precondition over here. Okay, let's go on. So now, the best we can do to encode preconditions in Java is by taking the logical negation and treat it as error conditions. That's the best we can do. Okay? And now, how can we do it? Okay, so now you can see that for divide, you're going to say it throws this exception here if y is equal to 0. You can see y is equal to 0 is logical negation of y is not equal to 0. Okay, so that's the point. Okay, that's about version 1. Okay, so now this is a really important point. So when you want to do design rather than implementation, you want to guide your design preconditions as the valid inputs to say what valid inputs can allow me to provide the service you want, rather than saying what errors am I going to crash my program and give you an error. Okay, so that's really the point. You can read it through. Okay, so now we want to do version 2. Okay, for version 2, we're going to just accept in Java the best we can do exceptions. Let's see how the version 2 will look like. Let's go to version 2. So we got account version 2, v2, and then you can see that for the constructor over here, we say If the balance is less than 0, then we are going to give you an exception. And we also had some very clever mind last time to say this error condition here is not exactly accurate, right? Because, well, do you know why? Let's review that very quickly. Let's go to version 2. Think about this. If this is satisfied, I'm going to give you an error, right? But this may not be good enough, because what if I pass 0 over here? What does that mean? Is 0 going to trigger an error over here? No, because 0 less than 0 is false. That means I wouldn't go to this branch. I will actually go ahead and do it. In that case, I'm actually going to violate requirements number 1, because the balance should always be positive, right? However, you can see this second version here, I make that mistake for the error condition there. But there's nothing there to actually report the error, to say the resulting balance, which is 0, is actually illegal, right? That's another criticism for version 2. Okay, just keep that in mind. So in this case, we do need to check something after you call the constructor, okay? And similarly, when you say amount over here, why do I lose? Okay, amount over here, okay. Amount less than 0 here, that's also not very good, right? Because what if the value I pass over here is exactly the amount? Oh, sorry, it's exactly the balance. That's what I meant to say. It's exactly the balance. You know what? I circled the wrong thing. What happened to me? Let me just be precise, otherwise you'll be confused. This one here is also not good, okay? So now you can see that if the amount I'm passing is exactly the balance for the account, what's going to happen here? So that means amount minus the balance minus balance will give me 0. Again, I violate requirements 1. So this is also not good. This also wouldn't report, because you can see balance less than balance will also be false. So I wouldn't trigger the error accordingly. So there are 2 sources of error, logical errors over here, which cannot be caught by any contract violation in version 2. Okay? And there are other things that are actually not very good for version 2. Okay? You guys know about from 2030, if you say that from the supplier side, if I can throw exception, you can see that as part of the interface over here, I say throws. Maybe I should use a different. Let's say I say you can throw this exception or this exception. So what does that mean? That means when I try to call this method here in the client side, I need to say try this method call, but I need to catch and catch, right? Depending on how many exceptions I might have. So you're somehow, for me as a client, I need to complicate my code using try and catch. If I can get away from that, why not, right? We have been a little bit more too used to Java code, the way Java does. You might be thinking this may not be so bad, right? But if you can do it easier, why not at the design level? Everything that can simplify your design, you should do it, okay? Okay, that's about version 2, okay? And let me just go through some slides, and then we'll go to version 3, which is what we haven't done yet. Okay, so now you can see that's the supplier side. We got 3 possible sources of errors. And now, let's say just show you one client over here. Let's say this client here, let's say we simply just want to call the constructor over here, right? And the constructor might throw this particular balance negative exception, right? That's why we got to do a try and catch. And even worse, if you look at the next one over here, if we try to use the constructor here, and also we want to call the withdrawal, how many possible errors might occur? 3. So that means we got to try and catch, catch, catch. And of course, in a more realistic project, you might have way more preconditions to check. Sometimes even postcondition, right? Precondition mainly. Okay, any question about this? We're okay so far, right? Yes?
Can we remedy this by, say, suppose we were to make a, I don't know, account and exception class, and then make all of these.
True. Yeah, however, yeah. Basically, what you're trying to say is, why can I not say catch exception? Basically, right? You want to just put a one single catch block. But the problem is, if I catch that, it's a very good question. Let me answer this in detail. You can get away from the complexity. I will prove to you why. let's say, let me just write it down over here. Let's say I still do, can I just call this block just B, okay? Oh, sorry. Good. So let's say I say try, the block of code over here, the same block, and now I simply say catch exception, right? That's basically what you're trying to suggest. That's the most general you can get. Any exception can be caught over there. But now the problem is, let's say inside, well, if you simply tell your clients something has gone wrong, it's not very useful to them. You want to be specific about what has gone wrong. So now, how can you actually determine what kind of error actually has occurred? You got to use instance of. So you got to say something like this. If, why am my Apple Pencil not reacting to me?
Why can't we put a message?
You may put an exception there. Let me just give me one moment. Okay. Guys, can you bear with me just 20 seconds? I need to reconnect my Apple Pencil, okay? But I'll keep talking. Basically, what I'm trying to say is you have to somehow do lots of instance of inside the exception. That's what you got to do. Okay, let me try again. Oh, that's not about connection because over here is loose. That's why. Okay, let me do it again. Let me reconnect, and then we'll be set. Give me just 20 more seconds. Quick time. Let me shut it down. Okay. Let me quit it. Movie recording. I should see my iPad now, I hope. Good. It's there. Okay, it's going to work. It's going to work. All right, let's come back here. Okay. Okay, what I'm trying to say is now it's going to work. Let's put it here. So you somehow you have to say, let me put it here, okay? Over here. If E instance of maybe, let's say this kind of exception over here. So that's a balance negative exception. So balance negative exception, and then I should do some action over here, right? Else if E instance of the second kind of exception, withdraw amount negative exception, and then I will do something else. You still cannot get away from checking the have a list of types of exception. What you just said was, if you just print a message, it's not good enough. Sometimes you might want to say, for this particular exception here, I might want to do something specifically, not just error message.
Like when you make an exception, you can put in a message in the exception, right?
Yeah, what I'm trying to say is the message itself is only a string. Sometimes you might want to do more than that. And also, why would you have to encode the string yourself? Because everything we're trying to do over here is somehow just required by the exception mechanism in Java. But if you can get away from this kind of scaffolding, why not? Something can just be done automatically for you, which is if you call the method or the feature, at the runtime it's going to tell you which kind of contra violation occurred. You don't even have to do try and catch. Okay? Okay, we'll see. How about reserve that, and then we can come back here. Okay, any other questions? Yes?
So when you catch, can you like catch the union of like 2 or 3 exceptions of contra?
Well, okay, this goes back to like a discussion for 2030, right? Basically, you can just put any class over there. Whenever you say catch some exception there, any subclass of that particular exception can be caught. So that's more like a Java discussion. I don't want to go too deep, okay? But the point is, if you want to use exceptions in Java, the unavoidable consequence is you have to do try and catch somehow. But we can avoid that. Okay? Okay, good. That's about version 2. Okay, over here you can see that for version 2, we do have some precondition violation in this case. Let's say you're trying to, let's say this case over here, let's say you're trying to withdraw minus a million over here. So that means this minus a million is going to match, is going to satisfy the error condition, right? So that's why it is going to actually throw the negative withdrawal amount exception and print out this message here for you. That's one possible action you can do. Okay? So version 2 is better than version 1 because we can handle some errors by using exceptions. Okay? That's good. Okay? But let's criticize about version 2, right? For version 2, but you can read it through, so you can see that right now. So but we still have the user try and catch. And now over here, more importantly, you don't really want the clients who uses this account code to pollute their code by using try and catch, right? That's the main point. Okay, let's go on to, so this is something similar, okay? You can see over here, it's just different type of exception being thrown when you try to withdraw something that's too big, okay? Okay, and then similar argument here. Okay, why is that not a good design? Okay, as we said before, line number 5 is not appropriate, the condition there. It should be if the balance is less than or equal to 0, right? That's one thing. And also line number 13 is also not appropriate. It should be the balance is less than or equal to amount, then you should throw the exception, okay? So that's the thing. However, it didn't catch that, right? Let's just do some manual execution over here. Let me go to version 2. And let me remind you about the requirements over here. Let's see over here. Whenever you see anything in your requirement to say something should always be true, that means it's a global property. Okay? Let me put it down here. So that means this is a global property for all the account objects. So that means every account objects, after it's been created and between any updates to the account objects, this property should always be satisfied. Let me give you one example from 2011. Can you come up with an invariance for balanced binary search tree? Balanced binary search tree. If you talk about arbitrary binary search tree, it may be ill-balanced, right? What about balanced binary search tree? Just roughly. Yes, you are talking about it. Yeah, you want to say something? Yes.
The subtrees should have no more than one equation.
Yeah, like yeah, exactly. So okay, so conceptually, and this could be an exam question. Let's think about this. There's a root. Somehow you want to say there's a left subtree. Maybe there's a right subtree. Let's say this is the height, and this is height 1, height 2. You want to say h1 minus h2, something like the absolute value should be less than or equal to 1, or maybe less than or equal to 2, something like that. Okay? You can look up your definition for balanced binary search tree. That's another invariance. So the invariant is a very important property for you to pick up. Okay? It's very important. Okay, so that's something we're going to add to version 2. Because for version 2, the code over here does not really reflect over here the global invariance, which is the balance should be larger than or equal to 0, is not encoded here. It's simply not. Okay? So now, can you think about how should we encode it? Just some rough idea. How can we encode it? That will move us to version 3. How do we encode it?
In the constructor.
In the constructor, that's good. That means every time when we want to create a new object there, account objects, we should always check if the balance is larger than 0. Would that be enough? Remember what I said before, the global property must be satisfied every time after the object is initialized and also between updates, which means every time if you want to modify the balance, you better do it as well. Yes? Assertion, some assertion there, but where should you put the assertion? Suggest some, I don't have line number here. Okay, you know what? Let me bring back to the slide and tell me which line would you like to put assertion. Let's say we can do assertion here. Assert, let's say balance strictly larger than 0. Where should we put it? Give me a line number. After which line? After line number 7, that's good. That's for the constructor. Good. Anywhere else? Hmm? Exactly. So after line number 7, because after creating the objects, make sure the object has been legally created. And also, after line 15, we also need to do assertion check, simply because any updates can potentially compromise the global invariants. Okay? Good. And you can see, one more thing before I say that. Okay. How about this? Let me just do something here, and then I will criticize about this solution here before I move to version 3 even. Let's say over here, if I try to add an assertion as you suggested over here to say assert the balance, I'll say B, okay, just for short, balance larger than 0. The second place is after this line here, assert B larger than 0, right? Right? Basically these two places. So basically after the withdrawal, after the constructor, we have to assert balance larger than 0. So now, what if I got 50 mutators here in this class? 50 times. It violates a principle for design which is called single choice principle, which we'll talk about a lot. Basically, too much duplicates. If you took my 2030 last year, I said your code smells. You basically repeat the same thing more than one time, which is a warning for your design. Wouldn't that be nicer if we can only have a single place in your class to say invariants over here, and then simply say balance larger than 0. That would be much nicer design. You don't have to repeat. Doesn't matter how many methods you have, just a single place. And the runtime system is going to check this property here at the end of the constructor and every mutator and accessor to make sure nothing will compromise the global property. Okay? And apparently this cannot be done by Java. There's no such keyword called invariants. And guess which one got this keyword here? iPhone, right? Okay, that's another reason why we chose it. Okay? Okay, good. Okay, that's quite a good look ahead for version 3. Let's go to version 3. Okay, so for version 2, you can please still read it through. Okay, so now basically we want to do invariants. Invariant here. Okay, I'll try to give you more examples as we go along the course. So every time you want to design your own class, think about the invariant. Oh, what about, let's say we have a student class for your students. What should be the invariants? I think I do have that example. Let me see. If I don't have it, I will ask you. Yes, invariant of CS major students. What's invariance? GPA has to be larger than or equal to something, right? I forgot, maybe 4.5, was it? Okay, maybe. Something like that. Okay, that's an invariance. Which means every time when you first start your program, we assume you satisfy the invariance, start with. And then every time after you take a course, we got to recheck your GPA to see if you still satisfy that. If it doesn't satisfy, that means it kind of violates the invariance being a CS major students. Yeah, it's a very good question. I'm trying to say just conceptually. Maybe initially we just assign to you, to begin with, your GPA is simply maybe the maximum or 4.5, you know, just conceptually. Yeah, it's a good question. Yes. Yeah.
You're saying that this has to be true throughout the entire lifetime.
Exactly. So invariant, you know, yes, let me just repeat what you said. That's exactly correct. The invariant must be true throughout the lifetime for that particular corresponding class.
Wait, but here comes my question.
Mm-hmm.
Okay, so let's say the example of the binary search tree.
Mm-hmm.
When you first update it, let's say you insert an element and it's unbalanced. Sure, you have to fix it, but
Nope,
it
nope.
violates, like,
Not the case. Okay.
It's
Yes.
not true
Yeah,
without-
okay. Your question was, for a balanced binary search tree, let's say it's a class, is it possible for the insert method there, can it violate invariance? The answer is no. That's why you got rotation, right? So which means as part of the insert method for your binary search tree, the balanced one, after you have done the insertion, the last part of the method should really restore the balance before you can terminate the method. So they are not separate methods.
Wait, but then in that case, it's not that the invariant is true at all times. It's only true after.
Good question. Good question. The question basically is, okay, very good question. I would like to clarify this. Guys, whatever discussion we have right now, even though it's on Java, but it does definitely apply to design in general, also for your Lab 1 and also for iPhone. Okay, so I will explain this. Basically, your question is, let's talk about balanced. Thank you. Thank you. Balanced binary search tree. Okay, let's say it's a class. Okay, I'll draw as complete as possible. Okay, let's say we have an insert method here. And then let's say we try to insert, we can even make it generic if you like. Actually, that's not a complicated matter. Let's say insert some integer, I. Okay, so that's the method. Let's say hypothetically, let's say there should be an invariant. Okay, I'll just say it is a comments. The invariant should be the tree is balanced. Okay, so as you can recall, you may be able to recall, to do insert, you got many different cases, right, to insert into binary search tree. Okay, so this will be where the insertion is done as part of the method, and then the second stage should be to restore the balance if necessary. So back to your question here. Apparently, at this point over here, possible invariant violation. It is okay. We only require that before the insertion occurred and also after the insertion occurred. The invariant is satisfied. You can temporarily actually violate this. It is okay, just temporarily. I'll give you another analogy. Any one of you taken a database course so far? Okay, that's okay. It's a classic example. I'll just show it to you. It's a very, okay, how about this? I'll just make the example over here. Let's say we do a transfer transaction. Transfer, let's say from and to, okay? Let me just make it more, maybe more understandable. Let's say transfer from Jim into Tom, for example. What should we do over here? Basically, the first step, let's say certain amount, let's say A, amount A. Well, I transfer from Jim into Tom. What I gotta say is Jim dot withdraw A, and Tom dot deposit A. Okay, that's over here. So you can see that these two lines are the complete implementation for your transfer, which is supposed to be executed as an atomic transaction. So now you can see that immediately after Jim.withdraw and before we call Tom.deposit, the states of the variables is somehow inconsistent, right? Because somehow Jim has lost his amount of money, but Tom hasn't got it yet, right? So that's somehow also inconsistent, but that's okay. We can think about each method call in the case of decide by contract is like a transaction. As long as the invariant is satisfied beforehand and afterwards. If you break the invariant in the middle, that's okay. Okay? I hope that answered your question. Good. Okay, good. Okay, let's go back here. Invariant of binary search tree. This one. What about just general binary search tree? Well, I talked about balanced binary search tree before. For that one, the height, the difference of the height should be less than or equal to maybe 2. What about just binary search tree? What should be the invariance? Anyone at the back want to try? It's a little bit test of knowledge from 2011. What should be the invariance for every binary search tree? I'll give you a little bit hints. Think about what a search property is. Yes? Well, I agree, it has to be sorted. Can you make it a little bit more concrete? The left node has to be right, less than or equal to right node. Still not very perfect.
I think the end node must be greater than the
You're getting there. Anybody? One more try, and then, yeah. Exactly. That's very good. That's very good. Okay. Basically, the invariant for the binary search tree, something like conceptually, something like this. Any nodes in the tree, all the nodes in its left subtree must be less than that, and all the nodes in its right subtree must be greater than that. And I would like to have another alternative version. If I have an in-order traversal of the tree, what should I get? Sorted sequence. That's another way to look at that. Okay, so both work. It's really a matter of how you express that. Okay, okay, that's about invariance. Okay, hopefully you get an idea. Invariance is really important. Okay, yes.
If you go to version 2 of the code,
Yes, of course.
no, not this one, the slide again.
Over here, right? Okay.
Yes, for balance less than amount.
Yep.
So in these slides, it says that it's not a good design, right? But that's an implementation error that can be caused by any unit tester, right? So
Not quite. Because you gotta think, okay, so over here we are thinking, remember this condition over here somehow triggers the withdraw amount too large exception, right? And this exception here is publicized as part of the API. And it'll be visible to the clients. So the client has to know exactly under what circumstances am I going to get this error. So that means we're giving some falsified information to the clients. So that's not good design. Okay, good question. Okay, let's go on over here. So, okay, now the best we can do for invariant is at the end of each method, each constructor, each method, we're going to put the assertion. Okay, so that's basically what we're going to do. So now the biggest criticism about using assertion is, well, for this, we're just using the invariant. We don't have to negate that logically. However, the assertion is not part of the API, which means there's no way for the client using your code to know what the invariant is. You can only rely on your Java doc to tell them informally. Okay? That's not good. Okay, let's look at version 3. Basically, for version 3, we are adding this assert here. You can try that because for assertion here, we simply this.getBalance larger than 0. If it is violated, we're going to give you this message here to say invariant violation, positive balance. That's for constructor, right? At the end of the constructor. The second place we got to put is at the end of the withdraw method here, we're going to say assert the same condition here, right? You can see these two, line number 8, line number 17 are exactly the same. As I said before, what about you have 5 overloaded constructors and 50 different methods repeated 55 times? You don't want to do that. You'd rather to put it in a single place to say invariance balance larger than 0 and let the runtime system deal with this for you. Okay? That's really important. And again, we talk about design, not really implementation. Okay, so now for version number 3, it's definitely better because now if you try to say withdraw over here, let's say Jim has 100, you try to withdraw 100, right? So 100 minus 100, you'll get 0. And 0 is not going to pass this assertion over here, right? Because this.getBalance at the end will be 0. 0 larger than 0 will be false. So that's assertion violation in this case, right? It does catch that. So the, version 3 is definitely an improvement to version 2, okay? But now we can have other issues for this version over here. Yes?
Does it subtract the balance?
Which one? You mean, which line are you talking about?
17.
17. Oh, it doesn't. It simply just do some Boolean check.
Okay.
It simply check to see at this point, at the end of the method, does the balance, is the balance larger than 0?
Okay.
Yeah.
So
Or thinking, yeah.
after we subtract the amount.
Yeah.
So right now the balance is at 0.
Okay, how about I go to version 3, and then I'll show you. Okay, the version 2, version 3 is here. Okay, version 3. So let's say this. Let's just make it very concrete. Let's say at the moment, let's say the balance value is, at the moment, let's say 100. Okay? So now, if you try to call the amount to be 100, that means over here, we're going to execute this line over here, right? So that means balance 100, sorry, let me put it here. So balance 100 minus amount, which is also 100, is going to give you 0. So that means this balance at this point, the resulting balance is going to be 0. 0 larger than 0, false. That's why I give you the assertion error, right? Maybe that answers your question, right?
So after this,
Mm-hmm.
now balance is still 0. If I go into
Oh yeah, of course. Assertion doesn't change anything.
Okay.
You simply try to check to see if things have gone okay so far.
Okay.
If it hasn't, you will throw the assertion error, right? That's what the contra violation means. Okay, it's a very good continuation from here. Guys, can you think about, okay, maybe I should give you a little bit hints, otherwise it's too unfair because I know the answer, right? Okay, how about this? I want you to look at this part here, the else branch. The else branch simply says if none of the error conditions above is satisfied, that means no errors, I can simply provide my service. Let's think about some very crappy supplier. They do something wrong. I'm not saying what they have done wrong, just in general. If they have done something wrong, do you think the current invariance over there is going to be strong enough to catch that? If you don't think so, can you give me one example of faulty implementation from the supplier? I'm talking about line number, just this line here, the else part, right? Apparently, we are lucky at the moment this supplier has done the right thing, right? But there's no guarantee. If we are simply we are using some supplier's code, it's like a black box to us. We just have no information about how they implement the thing. So now, can you see can somebody think about any example to say somehow the implementation is wrong, but the invariant can still be satisfied?
So if it's like this dot balance minus amount minus 1, the assertion is still true even though the balance is not.
Okay, it's a good suggestion here. Why don't we try? So the suggestion was, let's say we create, hypothetically, some faulty implementation here. I'll put it here. Okay, let's imagine, hypothetically, is this dot, I'll say B, this dot balance is assigned to this dot balance minus amount minus 1. Okay, let's try that. Let's say, hypothetically again, let's say balance at the moment is 100. And we are trying to say withdraw 50. And then what we're going to do is 100 minus 50 minus 1. We should get 49. Is 49 larger than 0? It is. It still satisfies the invariance, but no contra violation reported. So that means what we have got so far here is not good enough. It's getting there, but not yet.
How have we reached the contract?
Hmm?
Why did we reach the contract?
Because,
How is that reaching the contract?
it doesn't.
Yeah.
It does not. Okay, think about this. So we are talking about the green implementation there. So rather than say, we're going to say this dot balance is assigned to this dot balance minus amount minus 1.
Yeah.
That's apparently wrong, right? At the moment, the only check for contract we have is the assertion over there to check to see if the resulting balance is larger than 0 or not. Right? Good? Okay, questions?
We have to add some postconditions.
You gotta somehow add some additional check, which is called postcondition. Yes. Anything?
Oh, what if you write I++, and then does it jump over the assertion? If you
What
put
do you-
assertion in the next time, you just put I++, and you check this possible.
Well, basically, you got to do additional checks. I'm not sure what you meant by I++ anyway. Okay. Questions? Before I move on? Yes.
Professor, I was just going to ask, why would someone put it as this dot b minus a minus 1?
Oh, I'm just making one example. In lab number 1, I tell you what, okay, let me do a little bit preview for you. Lab number 1 is going to be more complicated than this, in which case, this is how I'm going to test your code. How do I test to see if your postcondition is good enough? I will somehow override the behavior of your feature or method to make it wrong. And if your postcondition is not good enough to catch my wrong behavior, then that means you'll lose the marks. But I will show you exactly how to do the test, so you can also test yourself before your submission. Okay? But of course, this green one here, I agree with you. Usually supply wouldn't do that, right? Yeah, it's very elementary, but I'm just trying to make a point. The point is, if the supplier did something wrong, you want to make sure whatever assertion you put over there at the end is strong enough to catch that. That's the main point, yeah. The actual example here is irrelevant. You will never see that, I would say. Yeah, well, if you really see that, you're unlucky, right? Okay, that's about version 3. So we're gonna add some postcondition, okay? Let's just see what a postcondition is, okay? Okay, that's how you can violate the invariance, and then it is not good design because somehow there will be no precondition, there will be no violation if you try to have the faulty implementation. Yeah, this slide you can just go over. Okay, let me just go to the next point. Let's now go to the final version. The final version. The final version is we're gonna add in postconditions. Basically, you can think, remember we talked about invariance before? You can think about invariance is the postcondition for every method, which means you gotta check the invariance at the end of each method. But the postcondition over here might be different from method to method. For example, the deposit postcondition may be different from the withdrawal precondition, right? The withdrawal postcondition. They might be different. Okay? Let's just have a look at the example. You might be a little bit still confused. So at the runtime, how does it work if we don't have any exception checking? So that's something I will go in detail with you to see. But for this simple example, how things will work together at the runtime. We'll get there, okay, after we have gone through all the 5 versions. Okay, so the postcondition, basically we want to check something at the end. Little bit practice, okay? Before we talk about precondition over here, which should be y is not equal to 0, let's say y is indeed not equal to 0. What about the postcondition? For you as a client, you want the postcondition to be as strong as possible, not too strong, of course, otherwise nobody can do it, right? As accurate as possible. How would you specify that? You want to write some postcondition on the return value. Let's say the return value for this divide is simply a double, okay? How do you express the postcondition? You want to draw some relationship between the return value and x and y. How would you express that? Postcondition is usually more difficult to write, usually, because you have to somehow consider more like a complicated relationship. Okay? Anybody want to try? Division, that's the simplest one I can think of, right? How should the return value be connected to x and y if I do a division? Huh? It should be a, oh, that's very, yeah. Well, the type tells you this is double, right? But what about the value itself? That would?
So the return value times like x should equal y?
No, you meant the return value times y should be equal to x.
Or
Yeah, right? Okay. Is that what you wanted to say?
Do we just try to catch any errors?
No, actually here we're not talking about checking the inputs, not really precondition. We're talking about postcondition. Somehow the postcondition will tell you the functionality of this method.
But if it throws an error, you won't get value.
No, okay. So the postcondition tells you how the correct behavior looked like for the method. If the correct behavior was not satisfied, then you will have the error, right?
I'll check division by 0.
Division by 0, well, that's already covered by the precondition, right? Remember, the precondition was y is not equal to 0. Okay, basically what Dawood said was actually exactly correct. So what I'm going to say is, okay, by the way, result is actually, there's something a little bit different in iPhone. In Java, you simply say return something, right? You don't really have a way to refer to the return value. In iPhone, you can always use the keyword result. We are saying that result, which is the return value for divide, times y is equal to x. Okay, that's a very easy postcondition. Okay, something like that. Let's not worry about remainder for now, okay? Or precision. Okay, this one's interesting. Okay, binary search again. Let's say binary search returns a Boolean, and then you want to search to see if x is in XS. How would you write the postcondition? By the way, the postcondition should be a Boolean, right? How would you express the Boolean? That's why I said 1019 is really important. Whatever you learn about predicate logic is applicable here. Can anybody try to give me a logical expression that will catch the postcondition for this? Yes?
If the value that you're looking for is in that array,
Mm-hmm.
find it in like the subarray that you're looking in.
Uh-huh.
That's the closest.
Okay, you're getting there. You're getting, basically, let me help you a little bit. Basically, what she said was, let me try to write it down over here. Okay, so we talk about binary search, and then we have x, xs, and then it returns a Boolean, right? Basically, you're trying to say, you're doing a case analysis, basically, right? You're talking about a case where if x is actually in XS. That means the result is actually true. Something like that, right? And I can easily put another case here. I can say and conjunction here. If X is not in XS, that implies result should be equal to false. Can anyone simplify this for me just into a single line? It's too wordy. It's correct. Nothing wrong with it, but we can make it better. Biconditional, I like that, if and only if, right? So what this is completely logically equivalent to result if and only if X in XS. This will be useful for your lab 1. You might need something like that. Something like that. Not exactly the same, but something. Okay? So guys, please, I will do have some slides for you to review some core concept about 1019. You can refer to the slides. I'll point them to you. Okay? Let's go on. Okay, so now let's go on to the next one. Okay, so the best we can do, again, is to do assertion, right? So you can see that at the end of each method now, what we gotta do is we gotta do assertions for checking the invariants. Also, we gotta do the assertion for checking the postcondition for this particular method. You can see how things were accumulated manually for you, right? Okay, again, the postcondition, the invariants, since they're assertions, they are not part of the API. The client has no idea whatsoever what the invariant and postconditions are, unless you put it in the Java doc, which is kind of informal. Okay, that's about version 5. Okay, now I want to ask you this. Okay, what should be the postcondition for withdrawal? Let's think about it before I show you the code. How about that? Let's say I want to do withdrawal. It's easy. I want to say withdrawal takes amount. Somehow the amount has to be subtracted from the balance, right? How do I specify the relationship here? It's not really returning something. It's more like a mutator. How do I specify the postcondition for mutator? Anybody want to try? And then I'll give you how it should be done properly. Just try, okay? You deduct, okay, you're talking about specific value, right? Here, we're just talking about amount, right? The amount is a parameter, right? Yes? Okay, you say the new balance should be equal to the old balance minus amount. So here, the postcondition itself is trivial, it's easy to understand, but the most important thing is, whenever you talk about postcondition, why is it so difficult to write? Because you talk about two different domains, old values before you try to execute a method, and the new values, or the resulting values after you execute the mutator. So you talk about two copies of the same attributes. You want to draw some relationship between them. That's why it's a little bit difficult, okay? Let me give you one example. Okay, withdrawal, let me just go for withdrawal and then I'll give you that example, which is slightly more complicated. Okay, let's say this one here. So now how do we do it in Java? In Java, there's no such a keyword to let you denote to say, I want the old copy for this particular attribute. No such a thing. We can only get away from that by declaring the values by ourselves. That's the only way. Okay, let's see. That's why you see something like this. I'm saying O balance is equal to this dot balance before I try to execute the body of the withdrawal. And do whatever that's necessary. And then after that, when I say this dot balance again, that refers to the new balance. That's why you can see this dot gap balance, which is new, and O balance is old, right? I'm comparing the two. And imagine that if you want to write some complicated postconditions, which involve 5 attributes. Well, how many declarations do you need, like line number 4? 5, right? Again, it doesn't scale up. And IFO does have an old keyword for you to refer to the before state values. That's why IFO is so suitable for design again, okay? So now let me give you another example here. That one will be interesting for you to try, okay? And then let's go through that example. Okay, question for you. Think about it. Let's say I have a mutator here. I'll just say void. Let me just make it more precise for you. Let's say we have a class over here. just called array. Inside, we simply have an attribute integer array A. And then I have a mutator over here. Let's call that updates. Let's say I want updates at index I to a particular value. Let's say integer, I'll say V. So don't get confused. The I here is where I want to update the array. I only want to update a single slot of the array, only a single slot. And then I want to update that particular slot to have a new value called V. That's what I want to do. Okay? Okay, for example, if I used to have something like this, let's say over here, used to be 2, 3, 4, 5, 6. If I say updates to index 3, updated to 7. So what does that mean? That means go to index 3, 0, 1, 2, 3, and then update it to 7. That's what I meant to say. Okay? Now, precondition first. What will be the precondition? Precondition. Yes, yeah. It shouldn't be it should not be too large and should not be too small, right? Okay? So let me just write it down. Okay, that one's easy. So basically, I'll just put in math. 0 less than I and less than a dot length. Less than or equal to. It can be 0, right? Start from 0. Okay, now, you want to say something? Postcondition or precondition? Yes.
The value that we're trying to change, the old value,
Mm-hmm.
has to be valid or valid.
Oh, actually, we can change it to any value. You can even try to say, I want to say update index 3 to 5. That's fine.
No, but like you have an integer array. You can't change 7 to dogs or cats.
Okay. Okay, basically what she's trying to say is, what happened if I try the following? If I say updates 3, you said, did you say cat or dog, right? Let me say dog. It's a very valid question. Actually, I don't disagree with you. It's a very valid question. Do you think this will give you any runtime violation? Or even earlier? It's compilation error. Would this even compile? No. The type checker for Java or Ivo or any other programming language is going to say, you're expecting integer v, you're giving a dog, string literal. It wouldn't even compile. You don't even get a chance to execute your code. In fact, if you try to submit this code for lab, 0. Huh? Sorry? No.
No marks for effort?
Well, you know what? It's a good question. Should you get marks for efforts?
Like it's somewhat right, but
We can talk in private, but not necessarily. You know, that's kind of the mindset we have back in the grade school. That's how we teach our kids, right? But we're adults. But we at school? No, it's old school. Yeah, old school. Yeah. Okay, any question? Okay, so back to your question. You understand the issue, right? It's a different level. It's a different category. We're talking about compilation. We're not even talking about runtime.
Oh, I completely missed the fact that you had integer.
All right. Anyway, any other questions? That's okay. No problem. It's a valid question. I like that. Any other questions? Okay. Now, postcondition. Okay. Anybody try? I want as complete as possible. How about I give you a little bit hints to save our time? If I put a postcondition like this, let's say the resulting array A at index I should be equal to V. Right? For example, over here, A at position 3 should be 7. That's a postcondition. Is that good enough? I heard no. Okay. No? Yes? No? Anybody think that's yes? If you think so, please just let me know. Nobody think that's yes? Okay, if you think no, why no? Why?
What if the previous value is 7?
What if the previous value is 7? Doesn't matter. Doesn't matter. We just simply say, what if you want to assign that into, it becomes that value. Right? Well, it makes sense, no? It just makes sense. I would say it's necessary, but it's not sufficient. how can I create a faulty implementation for my supplier for updates that is going to violate this condition here? How is that possible?
What if we accidentally updated a wrong event?
Yeah, exactly. Exactly. What if my implementation looks like this? Let's try. What if I got something like this? Okay, faulty implementation. What if I say I'll do something normal here, and then AI is assigned to V, and then I go crazy by saying I minus 1 is also assigned to V. Would that satisfy this postcondition here? Absolutely. Because in your postcondition, you're simply saying, I only care about index I. I don't care about others, but you should care. All right? How can we, yeah, question.
Professor, are we going to basically check each and every...
Absolutely. You got to check that. That's exactly what you got to do for lab 1. But let's try to practice this. Let's not worry about IFO just yet. You'll pick it up very quickly. How would you specify this in math? Don't even think about Java, okay, for this one. It should make your life easier. How would you do this in math? Well, somehow you want to, okay, let me help you a little bit informally. You want to say, somehow I'm going to consider every index in the array from 0 until the last index. Somehow, if the index I'm talking about is not the one that's meant to be changed, everything else should remain the same. Basically, right? That's what is English. How would you put it in math? Anybody? You know what I should do? I should really get you guys grades in 1019 so I can pick up someone who got A or A pluses. Next time, I should do it. Anyway, I was joking. Anyway, anyone want to try? You need some for all. I can tell you what, you need for all, you need implication. You need for all, you need implication. Okay, let me open a new page over here. All the discussion we're having now is definitely relevant, so we are not wasting time, don't worry, okay? I know what I'm doing. So now, anybody want to try? I will help you with that. You do, by the way, you do know the difference between this and this, right? Okay, good. Okay, it's an aside. Okay. Okay, for every? Okay, how about we try? For every I, you're saying in AI? I tell you what, if you think about this, if you say for every I in AI, you're only talking about the elements in the array, which means where you are in the array doesn't really matter. I would say it's the wrong path. Okay, guys, let me help you even more. Okay, we're doing this together. Let's say if I is in the following interval, from 0 until a.length minus 1, all the indices. It is the case. And then I need some Boolean expression. Basically, I want to say the following. If the current I I'm considering is the one that's meant to be changed, it doesn't matter. If it is not the one that's supposed to be changed, it better be the same as before. Okay, we need some implication here. Let me help you even further. One variable will be enough. I can tell you that is enough. And I would suggest, for our clarity, I would suggest we rename this. Oh, that's too big, sorry. I will rename this variable here to be J. Okay, and don't forget the signature of the method looks like this. Updates I to be V. Okay, just a reminder. So we got I and J.
Do we need to make a copy of the values of the old array beforehand?
Yeah, we're not talking about Java. In Java, yes, you do, indeed. But now let's talk about math. You can just use the old keyword like in iPhone. Yes?
So for all j that is not I, if the arrays are the same?
The element should be the same, right? Okay, I think you're getting there. Okay, let's write it out. The antecedents is we only care about the antecedents where I is not equal to j. Right? If I is not equal to j, what does that mean? A at j should be equal to the old value of aj. And remember, we also got a previous post condition there, which will handle the case that's ignored. Well, that's kind of when the antecedent is actually true, right? Sorry, the antecedent is false. We also got A, I is equal to V. So these post condition 1, post condition 2 will make things complete. That's really what I meant by complete. If you only got P2, that's not good enough. You have to have P1 and P2. Does it make sense to you? I would say this is a very common pattern for this course, and also a very common pattern for the software we're going to deal with. Okay? It's not really complicated. The only thing that's going to be a little bit more complicated than this is when we have nested quantifiers, which I will talk about next time, but not yet. Okay? Any question about this before I move on?
Professor, I have a question. Is it possible to sort of merge postcondition 1 and postcondition 2?
Good question. Is it possible to move P1 and P2? Absolutely. How do we do it? Okay, I'll just put it here. You can say and I is equal to J implies A I is equal to V. Okay? A very small question for you. Logically speaking, does it really matter if I put J here? It doesn't matter, right? Because you can see the antecedent there is saying I is equal to J. So it doesn't matter if I put I or J there, okay? So it doesn't matter. Okay, just want to mention that, yes.
So does it mean like that, like every time you do something, IFO keeps a track of the old values?
Yes, exactly. So in IFO there, if you can see the old expression there, which I'll talk about more in the rest of the course. Whenever you put an old expression in the post condition, IFO has a way to systematically and automatically cache all the values before you try to execute the method. Pretty much like what I did in Java, right? Everything's automated, and you don't have to do it by yourself. It's a very good question. The question was, what if the old value is a reference type? That means we need to cover something so-called a deep copy versus shallow copy. Let me delay that discussion until not long, maybe either this week or next week. Yes?
If in the body of the code, you take the integer,
Yeah.
so whatever the value is,
Yeah.
or the v or whatever, and it gets converted into a double or like a shorten or something?
Basically, the question is really about integer and double. Let's not worry about this kind of stuff. So the equality should really pick it up, which means you did something that's not precise. Okay? Yes?
In blue?
Yeah.
Is that equivalent to that last one?
Oh yeah. What? Okay. Let me make it clear to you. So now we got two versions for the post condition, right? Either you can either say this, the orange one, or you can say, let me try to see if this will be too not too messy. Or you can say this and this combined with this. Okay. Either way, either orange or green. If you want to put both, it's okay. Just redundant.
So if you use old, do you get back the previous value?
You just get a previous value if you use the old keyword, yes. We'll talk about old keyword a little bit later. Okay, good. Let's move on. Okay, that's about version 5. You can see if we had to do preconditions, postconditions, invariants, everything here in Java, would you want to do it? Or if you really want to do it, maybe, yeah, sure. Yeah, I wouldn't mind, but that's fine. Anyway, let's, I'm really trying to give you an idea. Even for a simple example like this, you have to build so much scaffolding in Java manually. And things are not so clear to you how things work together. But if we use a different language that can make things so explicit to you, and the runtime assertion checking is done automatically for you, wouldn't that be nice? So we can focus more on the design. That's really the motivation for using IFO. You may or may not agree, that's okay, but at least I will do my part to try to explain to you, okay? Good, let's now go to version 5. You can still go over the rest of the slide, we cover everything here. And this is more like a summary for all the versions. Okay, everything we have said already. Let me say one more thing about, again, we talk about benefits and obligation between a supplier and clients. So you can also go over them in this particular example. So now, this is a very important summary table over here. So now for the clients, what's really the benefits? So basically for the clients, they can get a post condition from the supplier, the service, and also they can make sure the objects they are using is valid. So that's invariance, right? Symmetrically, the post-condition invariant is the obligation for the supplier. Okay, so do review these tables very carefully to help you understand the rest of the course. Okay, one more summary here, and we still have 5 minutes, right? Okay, I will try to do as much as possible, but let's just go over this first. So now, design by contract in Java, it's doable, but not as pleasant as you might think, even for small example. So first of all, preconditions, we know that it's not exactly the surface condition, it's more like a logical negation. These error conditions. And then the clients will be bothered by the try and catch, right? It complicates the client's code. Okay? And for postcondition, we are putting that as an assertion at the end of the method. However, remember what the disadvantage is. Because postcondition is supposed to compare the old and new value. For the old value, you have to cache them, store them explicitly and manually yourself. Not very convenient. And also, assertion is not part of the API. So the client has no clue what the postcondition is. And similarly for invariants. Okay, that's all about the DBC in Java. What I would like to do now is to summarize to you how things can be checked at the runtime. Let's do it in 5 minutes. Hopefully that's doable. I do have a nice diagram for you. Oh, let me just first of all summarize what. So this will be how things look like in IFO. Compare this with version 5. Okay. So now let's go over IFO code very quickly. I want to do a diagram with you very quickly. I'll go in more detail in the beginning of next time. So now we have a classical account. We have 2 attributes here, owner and balance. We have the constructor here. We have a withdraw mutator. Okay. So now, how do we specify precondition? Require. And then how do we specify postcondition? We can say ensure, thank you. And then we also got invariants over here. Okay, so these are the 3 kinds of contracts. Okay, we're pretty much familiar with this. Now, let me do a 4-minute summary of how things can be checked at the runtime. Don't worry, I will do it again in the beginning next time. Okay, that's the diagram. Complicated, that's okay. That's okay. Whoa, what's that? Let me show you how good I can draw. Let's start from scratch. I'll do as much as I can, don't worry. Only a few minutes. Let's think logically. To create an object of type account, you got to call the constructor. So I'm going to say something like this. I'm going to call, let me use a different color. So I'm going to call the constructor. I'm going to say create. So that's the syntax in iPhone. I say account. And then the variable name acc.make. And then I want to make with amount n, a, and also name n. Okay, that's the thing I call. Okay, as soon as I call this constructor here to create an object, what should be checked first? Precondition for the constructor, if any. Agree? Okay, let's bring that to the context. In this case, I'm gonna do some checking here. Okay, let's say we do something here. And now remember the precondition for that is, I can simply say, let's say the precondition for the make is a larger than 0, right? I will check to see if that's true or not. If it is true, I can safely execute the body of the constructor. I can safely go to there. What if it is not satisfied? Well, if it is not satisfied, what I can do is, let's say if it is not satisfied, which means, let me put not the case, a larger than 0. What I should get is, I should get some precondition violation, right? Okay, let's see over here. So it's going to be precondition violation if the precondition is not satisfied, right? It gets either satisfied or not satisfied. If it is satisfied, I'm going to call the method, call the feature, call the constructor. And I would say, over here, I'll simply say execute. And then what I would get is some resulting states over here. So now what should I check over there? let's say postcondition first, okay? The postcondition over here, let's see over here, let me try to do something over here. The postcondition is going to be something like this. There's a reason I draw like this, okay? So the postcondition is ACC.balance is equal to A, and I'll put more mathematical notation, and also ACC.owner is equal to N, right? That's a postcondition. I want to make sure A and N is completely set. Okay, that's a postcondition. If it is satisfied, that's the case. What if it is not satisfied? Postcondition violation, right? Postcondition violation, and then I will just draw this one over here. It's going to be a postcondition violation. Postcondition violation. I'll just simply say not the case of the postcondition. Okay, anything else we should check? Invariants. Let me complete the picture, okay? We still have some time. Okay, now, so if the postcondition is satisfied, we do have some state for your objects. So now when I talk about states, so what do I really mean by a states? Okay, a little bit, well, for those of you who took 2001, this looks a little bit like an NFA, right? Non-deterministic finite automata. So state, well, usually when you, in 2001, when you talk about states, you just use an English description. Oh, you know what? I'll give you one example. Let's say you want to check to see, let's say I got I and J. I want to see if I is even and J is odd. Right? I would say one state would be both are even. Another one would be I is odd and J is even, right? So basically, I need to include all the possible values for the relevant variables. What are the relevant variables for objects? Attributes. So all the attributes must be in the states. In this case over here, we have to include owner and also balance. Okay, so now one more thing. And then after this, we have to check for the invariants. And check for the invariant to see if balance is larger than 0. If it is, then we do have a valid states. What if it is not? Violation, right? So that's the third kind of violation we might have, which is here. So that means we have a invariance violation over here. Does it make sense so far? And I would like to just make a conclusion here, and then we're done. I would like to just put this circle over here to be green. That means we start with call, and then we can only end up with a green state, which means that's a valid state for your object to begin with, to call withdraw or to call deposit, and that's the only valid state. But before that, we got to check so many things. Could you please review this before Thursday, and then we'll do it. Just come over. Okay, see you.